The National Electrical Code, or NEC, does permit grounding at a receptacle box using a bolt, lock washer, and nut as opposed to a 10.32 machine screw, provided certain conditions are met. The key is ensuring a reliable and electrically sound connection. The NEC addresses grounding and bonding requirements extensively, aiming to create a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices like circuit breakers or fuses. This, in turn, minimizes the risk of electrical shock and fire hazards. When grounding at a receptacle box, several NEC articles come into play. Firstly, consider NEC Article 250.8, which covers connection of grounding and bonding equipment. This section outlines acceptable methods for connecting grounding conductors and bonding jumpers to equipment. It emphasizes the need for connections to be made in a manner that ensures a permanent and effective ground fault current path. The connection must be secure and provide a low impedance path to ground. Secondly, NEC Article 250.12 addresses clean surfaces. Grounding and bonding connections shall be made such that there shall be no paint, lacquer, or similar coatings between the connecting surfaces. If supplemental pressure is used, the coating shall be permitted. Thirdly, NEC Article 250.64 discusses grounding electrode conductor connections. The grounding electrode conductor is used to connect the grounding electrode system to the service equipment or separately derived system. This section dictates how the grounding electrode conductor must be connected to ensure a reliable and permanent connection to the grounding electrode. The NEC provides flexibility in how grounding and bonding connections can be made, as long as the chosen method results in a connection that is electrically sound, mechanically secure, and meets the requirements for a low impedance ground fault current path. Now, let's delve into why a bolt, lock washer, and nut can be a suitable alternative to a 10.32 machine screw for grounding at a receptacle box. The primary concern is ensuring that the connection is both mechanically and electrically sound. A properly installed bolt, lock washer, and nut can achieve this. The bolt must be of sufficient size and material to carry the anticipated fault current. The lock washer is crucial because it prevents the nut from loosening over time due to vibration or thermal expansion and contraction. This ensures that the connection remains tight and maintains a low resistance path to ground. The nut must be securely tightened to provide adequate contact pressure between the grounding conductor, the receptacle box, and the hardware. It's important to note that the receptacle box itself must be listed for grounding purposes. This means that the box has been tested and certified by a recognized testing laboratory to meet specific standards for grounding and bonding. Listed boxes are typically marked with the grounding symbol, indicating that they are suitable for use as a grounding point. When using a bolt, lock washer, and nut for grounding, several best practices should be followed. Firstly, ensure that the surfaces of the receptacle box and the grounding conductor are clean and free of any corrosion or cuttings that could impede electrical conductivity. Wire brushing the surfaces before making the connection can improve the quality of the connection. Secondly, use a star washer instead of a flat washer. Star washers have teeth that bite into the metal surfaces, providing a more secure and reliable connection. Thirdly, use the correct size of bolt and nut for the application. The bolt should be long enough to accommodate the thickness of the receptacle box, the grounding conductor, and the hardware, with enough threads remaining to ensure a secure connection. The nut should be of the correct size and thread pitch for the bolt. Fourthly, tighten the nut to the proper torque specification. Over-tightening the nut can damage the receptacle box with the hardware, while under-tightening it can result in a loose connection. A torque wrench should be used to ensure that the nut is tightened to the correct torque. Fifthly, protect the connection from corrosion. Applying a corrosion inhibitor to the connection can help to prevent corrosion, especially in damp or corrosive environments. Now, let's consider some scenarios where using a bolt, lock washer, and nut might be preferred over a 10.32 machine screw. In some cases, the receptacle box may not have a pre-tapped hole for a 10.32 machine screw, or the existing hole may be damaged or stripped. In these situations, using a bolt, lock washer, and nut can provide a more secure and reliable connection. Additionally, using a bolt, lock washer, and nut can be advantageous when connecting multiple grounding conductors to a single receptacle box. A larger bolt can accommodate multiple conductors, providing a single point grounding location. However, it's important to ensure that each conductor is securely connected to the bolt and that the connection is properly insulated. Now let's focus on some potential issues associated with using a bolt, lock washer, and nut for grounding at a receptacle box. Firstly, the bolt may be too large for the receptacle box. If the bolt is too large, it can interfere with the insulation of the receptacle or other devices in the box. It can also create a safety hazard if the bolt protrudes too far into the box. Secondly, the bolt may be made of the wrong material. If the bolt is made of a material that is not compatible with the receptacle box or the grounding conductor, it can cause corrosion or other problems. For example, using a steel bolt with an aluminum receptacle box can lead to galvanic corrosion. Thirdly, the nut may not be properly tightened. If the nut is not properly tightened, the connection can become loose over time, leading to a loss of ground. This can create a safety hazard and can also interfere with the operation of electrical equipment. Fourthly, the lock washer may not be effective. If the lock washer is damaged or worn, it may not prevent the nut from loosening. This can also lead to a loss of ground. Now let's consider some alternatives to using a bolt, lock washer, and nut for grounding at a receptacle box. Firstly, a 10.32 machine screw can be used if the receptacle box has a pre-tapped hole and the hole is in good condition. Secondly, a grounding clip can be used to connect the grounding conductor to the receptacle box. Grounding clips are spring-loaded and provide a secure connection without the need for screws or bolts. Thirdly, a grounding pigtail can be used to connect the grounding conductor to the receptacle box. A grounding pigtail is a short length of wire with a connector on one end that is used to connect the grounding conductor to the receptacle box. In summary, the NEC does permit grounding at a receptacle box using a bolt, lock washer, and nut as opposed to a 10.32 machine screw, provided certain conditions are met. The connection must be mechanically secure, electrically sound, and meet the requirements for a low impedance ground fault current path. It is important to follow best practices when making the connection and to be aware of potential issues.